Hi all, welcome to GoClasses. I'm Sachin and today we are going to start linear algebra, which is very exciting topic. But before that, let me introduce myself. As I said, I'm Sachin. I'm co-founder and instructor at GoClasses. I've done my masters from IISc Bangalore and after IISc, I have been to Amazon as an applied scientist. I've also achieved GATE All India Rank 33. Now coming to Amazon, as you can see that I have worked as an applied scientist, which means that I have worked in machine learning models. So I have worked for machine learning models, I have developed machine learning models, I have launched machine learning models at Amazon. Now my work, since my work primarily was focused on machine learning, then it automatically means that I'm little inclined towards linear algebra and probability, like coming to the gate. Why? Because this machine learning is backed by linear algebra and probability only. So let's just see further that how it is how machine learning is basically using linear algebra and probability in this particular video, and then we will see some other motivation of linear algebra. Then I will also talk about that why this linear algebra is important for your interviews at IISc or IITs. Okay, so we will talk about the motivation in this particular video, which means why we need to study linear algebra, right? So now let's get started. That why we need to study linear algebra. So why do you think that we are studying linear algebra? Okay, the obvious answer could be that it is in the GATE syllabus. That I completely agree. But apart from this, can you guess that why we are studying linear algebra? I mean, why that is even in the GATE syllabus? So basically, there are many applications. Let me just tell you a few of the applications. Suppose that you have some data, right? In today's world, there is a lot of data. So whatever you are doing, I mean, when you are using your phone, when you are going to sleep, yeah, smartwatch or whatever you are wearing, any smart device you are wearing, that is capturing your data. You are talking to someone over the call, then maybe they are, if that call is being recorded, then that call can be used for the monetary purpose later, right? So everything is data. Whatever you are doing, like I'm recording this video, it is in data. So everything is data, and in the world of data, there is lot of need to interpret this data. I mean, see, as you can see, this is one form of data where someone has written I think a LinkedIn post and then they are talking about something, right? This is one form of data. You're talking to someone over the call, right? This is another form of data. So this is one person, this is another person, and this is basically called speech data. This is called text data, because someone has written some post that is called text data. You can have images also. Let's suppose this is an image of some X-ray, and then you might be having the image data also. So basically, there could be any type of data. I'm recording this video, then let's suppose that this video get recorded, and then we call it video data, right? So everything is data, but the difference is that the data format could be different. Something might be text, something is speech, image, video, whatever, right? Now, our main purpose is that how to make use of this data. This is our main purpose. Can you understand the intensity of the problem? That we want to make use of this data. So, let me write it here that the main challenge that we are facing, okay? I mean, we have the raw data, but what is the challenge here? Challenge is that how to make use of this raw data. How to make use of this raw data. So this is our biggest challenge, right? I mean, given this raw data, how to make use of this raw data, which means what I mean to say that I want to make use of this data. It means that I want to convert into some form, finally some form, such that I can understand this data. Our machine can understand this data. I mean, I can understand even in the raw form, which means the text I can read at something, but I want machines to understand this data, right? So basically, our challenge is that I want to convert this raw data into something. Then what is that something we are looking for? So basically, this is the raw data, and this raw data should be converted to something, right? Something such that it is interpretable by machine, such that data is usable by machines. This is my current challenge, and the answer is linear algebra. Yes, the answer is linear algebra, which means you can convert the data to something which is looking like a matrix. So see here that whatever format data you have, if you want to feed this data to a machine, but before that, I mean, if you want to implement some machine learning model or something, you need to convert that to some usable format, right? Some common format. I mean, need not to be a common format, but it should be some usable format such that my machine can understand. So if you directly feed this, I mean, you can basically you can directly feed this image, but might not be that much useful. I mean, my machine might not understand this very well. Otherwise, like, I mean, another way, what I'm saying is that, like, if you directly put it on the machine, then my machine may not be able to find out the more insight of this data. But if you convert that to something that is more meaningful to the machine, then maybe machines can understand this data in more meaningful way, right? See, if this is a text data, then I will tell you that how to convert. I mean, although that's not in the syllabus, obviously, but just to motivate the idea, I will tell you. But if the image data, then I think one of the trivial ways is that using the pixels. Obviously, there are many different ways to convert this image to a text to a matrix. But one of the obvious way you can think is the pixels, right? If this is a speech data, then maybe you can think of whatever we are speaking. Like, I mean, you can convert that speech to text, but in this text you are losing one information. And what is that information? I mean, you can first convert that speech to text, and then you can use the same method that you are using over the text. But there is one information that you might be missing, which is the pitch, right? Pitch at which we are speaking. So here the pitch is low, here the pitch is high. So basically, let's suppose that this is the data of some company which is making some product, the speech data. And then there is some customer that is calling to a customer care, and he or she is saying that your product is good, and that's fine. Like, I mean, the product was good in this aspect. But then suddenly he or she got some anger issues, and they are saying that, see, but it is not working. Like, the customer is saying, let's suppose that the battery is fine. I mean, I have purchased the mobile, but battery is fine, but the camera is not working at all. And here the speech is here the pitch is high. So we need to capture those kind of information also, right? We don't want to lose this information also, probably. So basically, this speech data you can convert to text and pitch, and then you can maybe convert to finally matrix. So basically, there are different ways to convert any data to a matrix, right? But ultimately, it's a matrix. So for my machine, it is just a matrix. And when I'm talking about the matrix, it is by default mean that we are talking about the linear algebra, because linear algebra is a tool to deal with the matrix. So LA is a tool to deal with matrices, right? I hope you understood. Now, our idea is that we have the raw data, we will convert that to a matrix, and once we have the matrix, then we will applying the LA. So basically, LA is everywhere because data is everywhere. I mean, I can say that without linear algebra, machine learning cannot even survive for even a minute, because like everything is just a matrix. Everything that you think of as a data is just a matrix. So machine learning is applicable on the data, right? So linear algebra, you can say, is a fuel of machine learning. I mean, without linear algebra, machine learning cannot go even a single step. It's a fuel. You understand the meaning of fuel? That without the fuel, engine cannot survive. So similarly, without the linear algebra, machine learning cannot survive. So that much importance this linear algebra is having in machine learning. Okay. So again, just to reiterate that why we study linear algebra, because linear algebra is a fuel of machine learning, and every type of data can be represented as matrix or as vectors, which means you have the data as a naive user, you have the data, but once you pour that data into the machine, that machine only understands the matrices. So this data has to be converted to the matrices before you put into the machine, right? And that's where the linear algebra comes into the picture. Okay, let's just see some example just to motivate you that how you're converting a data to a vector or to a matrix, right? Suppose you have one sentence which is, this is a laptop. What do you think how to convert that to a vector or to a matrix? What you can do, you can say that, okay, I will be using ASCII values, which means I will say that whatever the ASCII value of t, whatever the ASCII value of h, and whatever, like, I mean, with that method, I will be converting this to a vector. I mean, I will be converting that to a numeric values using the ASCII values, right? This is one of the way. You can say that, okay, whatever, let's suppose t has some ASCII value, then h, then I, then s, and then space has some ASCII value, then I, and then this s, and so on, right? But the problem with the ASCII value is that they are not meaningful, which means that you cannot say, I mean, with the ASCII value, you have the ASCII value of this and you have the ASCII value of A. You cannot say that, let's suppose, let me give you the concrete example. You have the ASCII value of, let's suppose, small. You have the ASCII value of, let's suppose, tiny. Then you cannot say that small or tiny are little bit similar, right? They are synonym to each other probably. Looking at the ASCII value, you cannot say. So that is why the ASCII value basically is not a meaningful idea. I mean, you can do it, but it is not much meaningful, right? So you understood the problem? If you convert this particular sentence to a numeric data using the ASCII values, then it is not meaningful for our machines. I mean, you can feed it, maybe there will be some output and so on, but it is not useful. I mean, not much meaningful, because it does not capture the semantic. There is something called semantic of the word. It does not capture the semantic, right? So to capture the semantic, what does machine learning scientists did? They have invented something called as word to vec. I mean, there are many methods actually. The very early method is called word to vec, which means what they does, they take this word, they convert that particular word to a vector. Okay, they convert that particular word to a vector using some method, and that is obviously not necessary for us. That is called word to vec. There was one research paper, I think, in 2012, and that paper got very much famous because that was a breakthrough, that how to convert a word to a vector. So that paper name is word to vec. Okay. Anyway, so let me not write it because that's not necessary. So what I'm saying here is that you can convert that word to a vector. You can convert this word to a vector, and then these two vectors, I mean, depending on the semantic, they will be similar or they will be different. So like for example, like this vector, you can say this vector is generally in machine learning, the vectors are of 512 dimension, which means that there are 512 numbers just for this. Just for one word, you have 512 dimension vector. Just for another word, which is you have 512 dimension vector. Just for A, you have 512 dimension vector, and similarly so on. Just for laptop, you have 512 dimension vector. So these all vectors are generally in machine learning are 512 dimension vectors. Okay. So how to convert that to a vector, that is obviously not needed for us, and this is a particularly machine learning topic. But the essence here I am trying to drive is that you are having vectors which are representing semantic of the word, which means that this vector can say that okay, is a helping verb. I mean, this vector can say that is a helping verb, is one article, laptop is noun, or something like this, right? I mean, they capture some semantic basically. Okay, but these ASCII values cannot capture any semantic. So that's the difference. So that is why we go for the higher dimension words. So every word is just a vector in machine learning. And if you want to convert this particular sentence, then what you will do, you will put all the vectors in one matrix, all the vectors in one matrix. This is the vector of this is the vector of this is the vector of age, this is a vector of A, this is a vector of laptop. So this particular sentence is a matrix for machine. And then from there you apply the linear algebra tools to understand this particular matrix. And there are many tools, like we will just study some of them. Okay. So as you see that every word is just a 512 dimension vector. Generally it's 512 dimension, right? Now let me quickly tell you that there is something called word embedding that is used for representing a word with a vector, which means if you are having this is a laptop, then as I said, there will be something called word to vec, and this is one research paper that researchers have published in the 2012 or 2011, I think. And then this says that you can convert every word to a vector. Now, just to tell you the effectiveness of this particular method, let me give you one example. Suppose that you have a vector using this method. You have a vector for king, you have a vector for man, you have a vector for, let's suppose, queen, you have a vector for woman. Suppose you have these many vectors. You have 4 vectors. I mean, that you got using the word embedding. So you have this vector which is 512 dimension, this vector which is 512 dimension, this vector which is 512 dimension, this vector which is 512 dimension. Now suppose these are the 4 vectors. Now just to tell you the idea that if you just subtract the man vector from king and add the woman vector, okay, just subtract the man vector and add the woman vector, then you are getting the vector of queen. The vector of queen. I mean, the vector that you got is basically the vector of queen. Now you can understand that it is actually capturing the semantic, which means if given a king, if it is not man and you added a woman, then it is similar to queen. Isn't it capturing the semantic? Do you really think that ASCII values can do that? Obviously no, right? There is no point in talking about it even. So basically, since this is capturing the semantic, that is why we use these kind of vectors in machine learning. So ultimately, machine learning starts with the linear algebra and ends with the linear algebra. Without linear algebra, it cannot survive. Okay. So I think that is enough motivation for studying the linear algebra. I mean, with respect to machine learning, we will see with respect to gate also. So basically, like this is one data. Let's suppose that is given to me, which is height, age, weight. I mean, why we are having the data? Because for the machine learning, like let me just give you this example again. See why we are having these data. Because see, given an X-ray, isn't it very nice if I just tell you, I mean, without consulting with the doctors, if I just feed it to my machine learning model, just to take a image and just to put it in the one algorithm, and then it will tell you that, see, this is the disease that you are having. Which means, given the data, if I particularly feed, let's suppose, thousands of X-ray images, and I tell you that, okay, if there is some problem in this area and that kind of problem, then the disease is this particular disease is there. Otherwise, this particular disease is there. Otherwise, this particular disease is there. Which means, if for the 1,000 different images, if I have 1,000 different diseases, then if I put the next image, which is unknown to my machine, then it will be using the machine learning. It will be able to tell you that, okay, most probably this particular image is having that kind of disease. Okay. So what I'm saying here is that, isn't it a nice thing that without any manual effort, if my machine is able to tell that what kind of disease this particular person is having just by looking at the X-ray. Similarly, just by looking at this particular speech data, isn't it nice that where the customer is satisfied, and what aspect and what feature customer is satisfied, and what feature customer is not satisfied? Which means, let's suppose phone battery is not working, but camera is working. So I mean, from this data, isn't it nice that we can do some aspect-based sentiment analysis? I mean, that's one topic in the machine learning, that is called aspect-based sentiment analysis, which means that in particular, what aspect customer is satisfied, what sentiment customer is having, in particular what aspect, what sentiment customer is having. That is widely used at Amazon, Flipkart, or any other e-commerce websites. Similarly, isn't it nice that given this particular data, LinkedIn can get to know the intention of this user, that, okay, this is basically this is that kind of post, so this particular user is actually writing that kind of post, and let's suppose there is some other user that is also writing that kind of post. Then isn't it nice that LinkedIn can just recommend that, okay, this particular user, let's suppose Sachin is also writing that kind of post, and this Harshit is also writing that kind of post. So what LinkedIn can do, LinkedIn can suggest me that this Harshit can be your friend, I mean your connection in the LinkedIn, right? So basically, I mean, there are many applications, I mean, to use how you want to use the data. There are many applications. So the only challenge is that, can we make use of the data? If we can make use of the data, then we can use it in any way, right? So these are just a few ways that you can predict the disease, you can recommend other users, you can know the sentiments. There are just few applications of this data, but this data can be used for some other purpose also, right? For some other purpose also. I mean, maybe they just want to know that, given this extra image, that if they don't want to know the disease, they just want to know the age of that particular person that is having this extra, right? I mean, similarly, instead of sentiment analysis, they just want to infer some other output from this data. So there can be many applications. I just told you few applications, right? Okay. So ultimately, you have the data, but for machine, it's just a matrix. So that's the difference, right? Now, as you can see that there are methods which actually works pretty well, which means they capture the semantic. If you have the vector for king, you have the vector for man, you have the vector for woman, then king minus man plus woman is actually a vector for queen. Isn't it very nice? I mean, that's just one demonstration that is telling you that actually these vectors are capturing the semantic, right? So similarly, if you have some other data, maybe need not to be I mean, the image or text or something, it can be the tabular form of data, then it is directly having the vector. So let's suppose this is one vector, which is height, age, and weight, which is telling you 3 dimension height, age, and weight. So basically, let's not worry about that what is the meaning of this and what is not a meaning of this. Let's just first understand the linear algebra, because these all is just a motivation to linear algebra, which is used in machine learning, right? So just one more motivation that I can give you if you want me to, which is basically recommendation engines. So if you have the embeddings, let's suppose that I know that this user is watching this particular movie, liking this particular movie, liking this movie, liking this movie, and this particular user is also liking this, and these 3 movies. This another user, first user is liking these 3 movies, but the third user is liking other 3 movies. But as you can see that 2 of these are common, right? 2 of these movies are common. So I can say that, see, that this particular user and this particular user, this user, first user and third user are almost same, only the one movie different. And then how can I make use of this data? I can say that, okay, this third user may like this one also because the first user have liked, and similarly this first user may like this one also because the third user has liked. So basically it's like that if I am liking 3 movies, you are liking 3 movies, but only one movie is different. So I will say that, oh, haven't you seen the Dark Knight Rises? Because I liked it too much. You may also be liking. So basically what I'm saying that our interests are matching. Since our interests are matching, it's just a one movie difference. You watch my movie, I will watch your movie, isn't it? So basically, like this kind of systems are used at Netflix and other websites. So basically, if you have any data, if you can convert that data, if you can have a vector for this particular user, okay, vector for this particular user, if you can convert that data to a vector, then you can make use of the data in many different applications. That's the crux of this story, right? So industries where linear algebra is used heavily is statics, chemical physics, genomics, and word embedding that I just shown you, robotics, image processing, quantum physics, and so on, right? So our mainly I talked about this word embeddings or neural networks or deep learning, but yeah, that is used in many places. In quantum physics also, that's heavily used. In image processing, in robotics also. Like I cannot even name a particular industry where it is less used. Okay, it is heavily used at all the places. Cool. Now, in the next video, we will talk about that why linear algebra is important for GATE. I mean, what is the weightage of linear algebra in GATE and so on, right? And why this linear algebra is important for the IIT's interview. So I will talk about that how you make use of this particular subject to get into IIT. So let's just start that particular discussion in the next video. Yeah. Thank you so much.